Hello, and my name is Milan, and this is our demonstration for Lab A5. I'm in Group 6 with Eric and Rachit, and over here we have our circuit. It is just the DAC being used here, and this is the MCP4821 DAC, and some of the connections we have going to the DAC are this is a 3.3 volt rail, so 3.3 volt is going to the VDD of the DAC. We have the chip select signal coming from the board, going to the chip select signal of the DAC. We have the S clock coming from the board, going to the S clock pin of the DAC, and we have the MOSI data coming from the board, going into the SDI pin of the DAC. And so over here, we have, this is the LDAC pin going to ground. This just constantly latches the data from the input register of the DAC to the output register of the DAC. So we'll always constantly be getting an output voltage every time we send data to the DAC. And this wire here, this is a this blue wire. This is for 3.3 volt going to the bar shutdown pin of the DAC. So this just makes sure that the DAC is not in shutdown mode. That's why we send 3.3 volt, and this is for our ground. This is just VDD of the pin of the DAC, and we have the output of the DAC being measured. This is pin 8 of the DAC. For the output, it is being measured by scope 2, channel 2 of the A82. So we have that measurement going on. And so we have the voltmeter here, and I'll just show how input some numbers here. So first I'll start with, and yeah, we also have the keypad here, just some of the connections for the keypad over there. So I'll just input some values. So I'll try 1, 2, 3, and so we get about 1.23 volt being measured. And then we'll also have 0, 0, 0, so 0, 0, 0. And when this LED turns on, that just says that a button, just tells you when a button has been pressed. So yeah, and then now we have almost about 0 volts being measured from the output of the DAC. And then next we'll try 299. And here we have 2.99 volt about being measured. And then we'll try just 3 volt, so 3, 0, 0, about 3 volt there. And now we'll try 3.29 volt. So we put 3, 2, 9, and here we are, almost 3.29 volt. Next, we'll try 3.3. So do 3, 3, 0, and here, almost 3.3 volt. And next we will see how the voltages are capped. So we'll put, this DAC is capped at 3.3 volt. So we'll try sending something that is greater than 3.3 volt. So we'll try 3, 3, 9, and we'll see what happens. So it still stays about 3.3 volt, but then we'll try 2.34 volt. So 2, 3, 4, and we get about 2.34. And now we'll again try 3.77 volt, but this will just be capped at 3.3 volt. So we'll try that. And here we see about 3.3 volt. And we'll try 2.34 volt again. So 2, 3, 4, And here we go, about 2.34. And then we'll try, lastly, we'll try 6.78 volt, which again will just be capped to 3.3. So 6, 7, 8. And then here we are capped at about 3.3 volt. And then lastly, we'll try seeing how this asterisk key works. So when you press the number, you can reset the number input by pressing this. So for example, I'll put 1, 2. So say that's not the number I wanted to put, so I could just reset it. And again, so nothing has changed. We're still at the previous output. And now I'll try putting 2, 3, 4. And so now it has changed to 2.34 volt after I've pressed the asterisk key to reset it. And so lastly, I'm gonna show the code here. So we have, and this here is our code. So we just have some prototypes, some configuration, just where it's accepting the 3 numbers, and then writing it to the DAC, and then yeah, that's our whole thing. Thank you.